Let's talk about ESD prevention. Now, a little disclaimer first. This video deals with electricity. So if you are not sure of what you're doing, consult with a licensed electrician to help you. Now, the best way to avoid static electricity and to discharge it is to use an anti-static wrist strap. So you got to have one of these. And in a pinch, you can get away with connecting one of these with the alligator clip to a large item of metal. Could be the chassis of a computer case, an unpainted portion of that. Just connect it, and then you're discharging to the case. And usually that won't damage the equipment. It's not the best way to do it, but in a pinch, it's good. And you can also touch the chassis with your hands, and you really should do that all the time before you handle any equipment. That could be very helpful if you're working on a PC. Now, we're talking about doing this for the small office, the home office, doing this on your own. In a large environment, in a lab environment, you're going to have all kinds of electrostatic discharge protection. For example, coats and shoes in a specific environment. So there's a lot to it. This is for the average person that's trying to do this. So the anti-static wrist strap is a must. You really want to have this. And in a pinch, it can work by itself with the computer case. But the better way to do this is to properly ground yourself and have the static electricity flow away from you and out to ground. So one way to do this is to use a device like this. This is a common point ground connector, and this is both ends that I'm showing here, and it's about a 10-foot cable. But what we do is we put on our anti-static strap. So we have the strap portion here. Put that on our wrist, connect the cable, and connect the other end to this. Now, generally you have this alligator clip, which again, I'm saying you can use this on a computer case, and it sort of works, but it's best to take this off and connect it to one of these common point ground connectors. So we plug it in here, and this way the static electricity is going to flow away from us through the anti-static strap, through here, through the cable, to the plug. And the idea is we plug this into an AC outlet. Now, this is where it gets important to be very safe. You want to make sure the AC outlet is wired properly. So if you're not sure what to do, hire an electrician who is licensed and have them test that outlet. They can test it with a circuit analyzer. Make sure that they have a circuit analyzer and that they will certify and stipulate to the fact that the outlet is wired properly to an electrical panel. But you can test these yourself as well. You can use a receptacle tester. If you do, you want to make sure that both yellows are lit. Any other configuration, and it's not going to be correct. The outlet won't be correct, and it could be potentially hazardous, right? Because you don't want to have the hot and the ground reversed, because that could actually send electricity back to you, or the neutral and the ground reversed. You also don't want the hot and the neutral reversed, because when that happens, the ground is ineffective. So you have to be very careful with this and make sure it is wired correctly. You could do that. You could check that with the receptacle tester. You can also check with a multimeter. And of course, you can use a circuit analyzer, but those are expensive. If you're not sure what you're doing, hire an electrician, have them check it for you with a proper circuit analyzer. Once you're sure that your outlet is wired properly, then you would plug this in. And the idea is that the static electricity flows through here, through this ground plug, out through the ground wire, and out to the electrical panel, and out to actual ground, however that works. The idea is you want to make sure you're connecting this to a properly grounded outlet. Now, instead of having the electricity flow into the computer case or just who knows where, now the static electricity from the buildup from your body is going through here, through this, out to the end of the cable, out to the outlet, and out to proper ground. So that's the best way to do this, right? So, but before we can actually accomplish this, we have to test some things. Okay, first thing we need to test is this plug itself. We want to make sure that we have continuity from here to here, from any of these ports that we can plug into to the grounding plug. So we'll use our multimeter for this, and we'll set this to impedance, to ohms, and we'll test each of these for continuity to this. So we'll plug one lead into one of these ports and the other end here. And you can see we're at, well, it's not a good connection. Let's see. There we go. You see we're at 0.2, sometimes 0.3 ohms. That's what we want, right around 0.2. And we'll do that for each of these ports that are on here. Here's the top right one, 0.2. Bottom. Make sure we have a proper connection. 0.1, 0.2. So that's all good. You can even test these across each other. Good. And you can do it with sound if you wanted to as well to test for that continuity. Good. 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 But really what you want to do is make sure you're down as close to zero as possible. For example, 0.1, 0.2, 0.3. Those are all good as far as the impedance goes. Okay. So we'll plug this in. The plug looks good. Now, we also want to test our anti-static strap. Why? Well, we wear this so that it can help to redirect the static electricity through here. And, you know, this video is called ESD prevention. We might be calling it ESD redirection. What we're preventing is damage that can occur to computer components from ESD. But what we're really doing is redirecting the ESD, the discharge, from here through here. But let's say that we, in the worst case scenario, this was plugged into the wrong type of outlet, or the outlet was wired incorrectly, or it's plugged into some funky surge protector or something, which I don't recommend. Well, then you could possibly get electricity flowing back towards you on this. And you, of course, don't want that. That can be very dangerous. So anti-static straps are equipped with a 1 mega ohm resistor in the strap, which will resist some or all of that electric flow if it happened to come back. So we want to test that. We want to test if that is working. So we'll connect the cable to the strap. And again, we'll set our multimeter to impedance and put a lead across the plate and the other lead on the plug. And we should be at 1 mega ohm or just under it. 1 mega ohm resistors have a resistance of 1 million ohms, and we are just below that. We're at 0.991 M for mega ohms. There we go. Just so you can see that a little better. But again, 0.991 mega ohms. So we're just under 1 million ohms, or 1 mega ohm. So that proves to us that this resistor is working, and that will provide resistance from any electric flow that might come through the outlet, if, just in case, you never know what might happen. Some type of surge or who knows what. Something's not wired properly somewhere, just in case. We also test this because these guys, these common point ground connectors, on the one end, they usually come with a 1 mega ohm resistor as well. So we'll test against this. And you can see we're just above 1 mega ohm. You can also test the ports. Good. The other port. Good. Collectively, you know, and what that does is, let's say you have a strap, but it doesn't have a resistor. They're supposed to, but what if it doesn't? Well, if that's the case, then this one takes over. and this will protect you. Let's plug this in and test the whole thing. From here to here should be 2 mega ohms. And it is just about exactly 2.001 mega ohms. So now we have 2 mega ohms of resistance against the unlikely but very potentially damaging occurrence of electricity flowing back towards us. So that's the way to do it. So we wear, I'll turn that off, we wear our anti-static strap. Got to be against the skin, got to have a nice flat connection against the skin here. Whatever's best for you. I like to keep it on the bottom usually. Get that flat connection there. Right, that's going to connect to here. And I also have an anti-static mat here. So when I'm working on computers, I'll place the case or whatever device on this and connect that to this, to your actual grounding system. Right? And we have a couple more ports here. We could connect more stuff. For example, I'll use another anti-static mat and I'll stand on that as I'm working so that I'm not standing on carpet and any friction is going to go through this and out to ground. Any static electricity that's created from that friction. Another way to do this is to take off this plastic piece here and connect this to the anti-static mat. So now the mat is grounded automatically, and we can now plug in 2 things into this. So a lot of options here, but as long as everything is grounding out to this and out to this and out to a properly wired outlet, that's the way to do it. Again, you can get away with just using the anti-static strap and connecting it to the chassis, the case of a computer, and touch the chassis at all times regardless of what you have. And quite often you can get away with doing that in a pinch without anything else, just touching the unpainted portion of the case. In addition, you can reduce the amount of static electricity that you create by not moving, staying stationary as possible, wearing rubber-soled shoes in an environment that's non-carpeted, tiled instead of carpeted, increase the humidity to reduce static electricity. There's also anti-static sprays. You could spray a carpeted area if you have to work there. And then clothing as well. We mentioned that you might use a ESD safe lab coat like this, which are usually made of polyester. So polyester clothing can also help. All right. And use anti-static bags. Put your equipment inside those while you're not using them, any components. And again, try to remember to stay stationary and touch the chassis of the computer, even if you have this type of configuration here. So everything I've been showing so far deals with the computer being not plugged in. And I get a lot of questions from people, should I work on a computer with the computer plugged in? And you can, but the idea is that we're trying to create an equilibrium between the user and the computer when it comes to voltage, an electrical equilibrium of sorts. So we're trying to keep the computer case and the user connected to the same type of ground. Now you can plug in the computer case, you could plug the power supply into an outlet, and that's also where you'd want to ground to, and you'd have to make sure that, and of course, this is wired properly. And you could use a variety of methods. Some people connect the alligator clip of the anti-static strap to a screw on the power supply. Some people will connect the plug of the anti-static strap out to the screw of an outlet cover, which should be grounded. You don't know, but you know, this can cause a lot of issues if you have the computer plugged in. Plus, if you have the kill switch on, if you have this switch on and it's plugged into an outlet, you got to remember that there is voltage being supplied to the motherboard. You get 5 volts there. So you're introducing an element of unknown. And so it's really better to have it unplugged and then have the user and the computer seeking the same electrical potential by being grounded to the same item. So what I have here is I have the computer case on top of the mat, and I have the mat connected to this, and also my anti-static strap connected to this. And any components could be placed on there as well. If you're not using the component, you could put the component inside an anti-static bag. If you're working with the new component, the beauty of the anti-static bag is that that will reduce, when you grab the bag, that'll reduce static as well, static discharge. So if you hold on to this for about a second and then pull the item out, the electrical potentials should be equalized. But again, it's better to just keep it all unplugged and have everything connected to the mat and out to something like this. Just anything you're going to work on, make sure it's on top of that mat. Maybe you have a second mat, and you could plug that into this additional port here, and you could put additional components on that second mat. And you might stand on a mat as well. The whole idea is to get everything equal with the voltages. The other idea is to have that 1 mega ohm resistor here and here. That will slow down the electric discharge, so that if you are handling any components, everything is slowed down through here. And that can reduce the chance of damage through static discharge, electrostatic discharge, and also can reduce the chance of you being hurt by another electric potential, whether it comes from here or from an external source. If you're handling some other device or power supply, or some type of live wire for some reason, or whatever electrical device. So that's the idea, and that's really the best way to go about it. Keep everything connected with that mat. And so that's about it for this video. Be safe, and again, hire an electrician if you're not sure about your outlets and your electrical system in your house or your business, and try to create that equilibrium of electrical potentials.